Welcome back. Next topic is space quantization and vector atom model. Two small topics. So first we can mention about what do you mean by spatial quantization. While we are discussing about the spectra of easiest atoms or lighter atoms like hydrogen, etc., it was enough with these two quantum numbers n and n. And later, in order to explain more complex spectra, these two quantum numbers are not sufficient, and we have introduced the concept of J. And in the initial concept, we are considering that an electron is revolving in either circular or elliptical orbits. That means it is a two-dimensional motion. As you know, the orbit will be always in two dimensions. But for explaining the more complex spectra, this concept of two dimension is not effective. We need the three dimensions. And in order to have the three dimensions concept, we are introducing the concept of space quantization and electronic spin hypothesis. So, as you know, or as you have already studied in your molecular spectroscopy topics, if you have an electron revolving like this will be the direction of your J value. And more correctly, you can write it as J star. So, when you are applying an external magnetic field, as you know, this plane of this orbit or this J direction will have an angle between the external magnetic field direction and this direction of J. So, according to our concept of quantization, this J can orient or J can point only in such directions or only in directions such that the projection of this J into the direction of external magnetic field will be a whole number, that is non-zero. So that concept will give you the idea of space quantization, and the projection of that J value in the external magnetic field direction is normally written as another quantum number mj, which is known as the magnetic quantum number. So your spatial or space quantization introduces this new quantum number known as magnetic quantum number. And also we have the concept of spin, and that we have already mentioned, which is written by the letter S, and it can have values plus or minus half. So now we have introduced the quantum numbers like n, which is known as the principal quantum number. Then you have L, which is known as the orbital angular momentum quantum number. You have spin, that we are writing with a small letter s. Then J, normally known as total angular momentum, that is the sum of L and S. That means spin angular momentum and orbital angular momentum vector sum is known as total angular momentum. And the magnetic quantum number mj. the value of n can be 1, 2, 3, etc. And that of L can be, for a given value of n, this L can take values 0, 1, 2, etc. up to n minus 1. And the value of spin can be plus or minus half. And that of J can be, normally you are writing it as L plus or minus S. And that of magnetic quantum number can be minus J to plus J. That means you are considering it as minus J plus 1, minus J plus 2, etc. J minus 1 up to J. That means this Mj can have values 2J plus 1 values. This is the normal considerations. And since the orbital and spin motions both are quantized in magnitude and direction, we can consider them as quantized vectors. That is why this atom model based on these quantized vectors was termed as vector atom model. So that about space quantization and vector atom model. In the next video, we will be discussing with the magnetic effects. That means your effect of magnetic field on the electronic spectra of atoms. Okay, thank you.